Hello, everyone. Welcome to the April 2023 Recreational Astronomy Night meeting of the RASC Toronto Centre. My name is Paul Markov, and I'll be your host for this evening. We are at the Ontario Science Centre tonight in front of a live audience of about 20 people. We apologize for the late start. We had some technical difficulties. To our online viewers, a reminder that we have resumed meetings in person here at the Science Center, so if you can, please join us next time. For those who definitely cannot make it in person, rest assured that the live broadcasts on YouTube will continue. Thanks to our capable AV team comprised of Andrew and Betty Reed, Ward Legros, Enya Cholucci, and Reza Mohammed. As you know, I'm always on the lookout for presentations for these meetings. In fact, we have one more opening for the May 3rd meeting. If you have anything in mind, please get in touch with me. Future meetings, which occur on the first Wednesday of each month, also have available time slots. Now, regarding the technical difficulties, we were supposed to have 3 presentations this evening, one of them remote. And that was John Percy talking about variable stars. Unfortunately, due to the technical difficulties, we're not able to have John present to us this evening, so we're down to 2 presentations. I'll reschedule John for a future meeting. So the 2 presentations are going to be Arnold Brody presenting the sky this month, and Frank Dempsey, and will talk to us about aurora forecasting. And then we have our president, Tom Luton, to take care of the announcements. And we expect to be done around 9:30. Well, now probably earlier than 9:30 due to the missing presentation, although we are running about 20 minutes late. All right, so if you're watching us online and have a question, please enter it in the YouTube chat box, and Enya will ask the question on your behalf to the speaker here. For in-room questions, hang on and we'll get you a microphone so we can all hear your question. And show of hands, do we have anyone here for the first time? We have 2 or 3 people or so. Yeah, very good, welcome. And for those online, if you are attending one of these meetings for the first time as well, please let us know through the chat box and introduce yourself. So let's get started with Arnold and the sky this month.
Well, thank you, Paul, and hello, everyone, here and online. We'll take a look at the sky for the rest of April as it appears from Toronto, and times will be for the Eastern Daylight Saving Time. As we see what's up in the sky this month, I'll suggest a few targets in the sky and on the moon included in these observing programs, in some of them anyway. What you should do is search RASC Visual Observing to learn more about these programs and download their observing lists. Lists for deep space objects will include their RA and DEC coordinates, so I won't clutter the slides with them. Now here are some highlights for the month. On April the 8th, we are 366 days away from a total solar eclipse that passes through Niagara, parts of southern Ontario, through southern Quebec, and into Atlantic Canada. Now, that's not exactly a highlight for this month. But who can't wait? I mean, we've been talking about it for years, and now finally on the 8th of April, we will be on the final lap. And yes, there is a leap day in February next year. Now, back to this year, on the night of April 9-10, there's a nice pairing of the moon and Antares. Mercury reaches greatest elongation on the 11th. That same evening, Venus strikes oppose with the Pleiades. On April 14, Mars comes very close to Epsilon Geminorum. New moon arrives on Thursday, the 20th, so Saturday the 22nd is the best Saturday night of the month for deep space, and I'll use that Saturday night when looking at the sky. That Saturday night will feature a lovely grouping of Venus, a thin crescent moon, and the Pleiades. And the Lyrid meteor shower peaks that same night. Friday, April the 28th, marks the kickoff of the 2023 season of public stargazing at Millennium Square at the south end of Liverpool Road in Pickering. Now, there is a benefit, in addition to all those highlights, there's an important benefit in observing the planets and stars in April. The observing window is reasonable in April as suggested by the width of the hourglass in S&T's almanac between April 5 and May 2. Now, I include astronomical twilight with night in what I call the observing window because planets and bright stars can be seen by the time the sun is 12 degrees below the horizon. Now, tonight, the observing window starts at 20:55, call it 9 p.m., and is nearly 9 hours long, and night fills the middle 7¾ hours. By month's end, or May 2, the window will shrink by 1 hour and 23 minutes, and night a bit more. The beginning of April sees the moon growing full and washing out deep space targets with the pink moon or breaking ice moon among many names for the April full moon occurring on the 6th. And I should point out that pink moon does not mean the moon is pink. It means that's the time when the pink phlox flower blooms in early spring. New moon finally arrives on Thursday the 20th, making the following weekend the best of the month for deep space. And that date in red, well, that's my second plug for stargazing at Millennium Square that night. Now, let's take a look at that Saturday night after new moon on April the 2nd, or April the 22nd, Saturday, April 22, and a 2-day-old moon is hanging out near Venus as the sun is setting. We'll take a closer look at that pair near the Pleiades later on. At the cusp of night, you have about a half hour or so to catch targets along the Perseus arm of the Milky Way before they are too low and set in the murk, and you can say goodbye till next winter. We can then turn our attention to 3 constellations at or near your meridian as night begins: Cancer, Leo, and Coma Berenices. Cancer is a faint constellation with its 4 brightest stars, magnitudes 3.5, 3.9, 4, and 4.2, which can be a challenge to find in urban glow. To find Cancer, you can probably start with the sickle of Leo and just look to the east about 20 degrees to find these faint stars. The 3.9 star in the middle is Delta Cancri, which lies almost perfectly on the ecliptic. That makes it subject to a series of lunar occultations, with the next new round of those occultations starting in about 4 years. Now, from Delta, slide about 7 degrees southeast to Alpha Cancri, and what happened? There we go. From there, it's less than 2 degrees west to find Messier 67, a rich open cluster that lies 2,800 light years away. Its angular size is ½ degree. Now, I'm not sure why, but this is known as the King Cobra cluster. Its 500 to 600 member stars collectively shine at magnitude 6.1. The cluster is around 4 billion years old, and that's about the same age as our sun, and it's one of the oldest open clusters known. And after those 4 billion years, the hottest main sequence stars left are class F and cooler. The rest are red giants off the main sequence, and you may also notice some blue stragglers whose origins are still a bit uncertain. They could be stars that formed much later than their siblings, so they haven't had a chance to go off the main sequence yet. Or they could be the result of 2 stars merging and forming a more massive, hotter star. More than 100 of the cluster's stars match our sun in class and age, so this is a good concentration for those searching for extrasolar planets around sun-like stars. There's an interesting double star in Cancer, magnitude 5.2 Zeta Cancri, a little less than 8 degrees west of Delta Cancri. Its Arabic name is Tegmine, meaning shell of the crab. The 2 components not fully separated in Peres's drawing oh, I'm sorry, I skipped a line. Tegmine is actually a triple star system, as seen in this sketch by Jeremy Perez from 2006. The two components not fully separated in Perez's drawing, those are called Zeta 1, and the other star is Zeta 2. Now, the Zeta 1 stars are orbiting each other. They complete an orbit every 60 years, and they reached their maximum separation in 2020. Now, we are 3 years since max separation, but they should still be easier to split now than they were for Jeremy 17 years ago. Moving over to Leo, we're looking away from the plane of the Milky Way and into the realm of the galaxies. And there's a bright one staring Leo right in the face. 1.5 degrees south of Lambda Leonis, you will find NGC 2903, glowing at magnitude 9. We see the lone galaxy inclined 60 degrees to our line of sight, and it's 30 million light years away. Notice how bright the core is in the middle. Often we will see the center of a large galaxy look a little bit yellowy from aging stars, but we have gas inflowing along the bar, and it has triggered starburst activity. 700 solar masses of stars are being born right in the middle, 2,000 light year radius, right in the very center of that galaxy. 700 new stars a year, which is enormous. Our entire Milky Way galaxy, by reference, only makes 7 new stars a year. So that's quite the starburst activity happening there. Leo is crouched down over 2 groupings of bright galaxies. The first is just 2 degrees below Kappa Leonis, about halfway between Alpha and Theta Leonis. It's known as the M96 group, and in a telescope wide field, you will see 4 of the group's members. Let's see them. Oh yeah, there they are. M95, M96, M105, and NGC 3384. This group lies 37 million light years away. And if you pan around in the neighborhood, you will find more galaxies, including other M96 group members that are marked here. And 2.5 degrees southeast of Theta Leonis, you will find the M66 group, also known as the Leo triplet. It's 35 million light years away, so it's 2 million light years closer than the M96 group. But many cosmologists feel that they are both members of a much larger group. Now, NGC 3628 is nicknamed the Hamburger Galaxy. And that's because there's a thick dust lane bisecting the view we have of the galaxy edge on, slicing it into a sandwich. It's classified as a non-barred spiral, though research hints at a bar pointing straight at us. Bars are common in interacting galaxies, I should say. And the 2 nearby Messier galaxies, they must be hungry because they're pulling on that hamburger. On to Coma Berenices, which is Latin for Berenices hair. Gamma Comae Berenices and over a dozen neighboring stars on the cusp of naked eye visibility form softly glowing cascades that in ancient times, up to a couple of hundred years BCE, were often described as the tuft at the end of Leo's tail. But in 245 BCE, when Pharaoh Ptolemy III returned home safely from the Third Syrian War, his consort, Berenices, cut off her long tresses and placed them in a temple as an offering of thanks to the goddess Aphrodite. When the tresses disappeared overnight, Ptolemy, he was pretty upset. But quick-thinking court astronomer Kenan of Samos declared that Aphrodite had accepted Berenices' offering and placed her hair up in the sky, pointing to that hazy cascade of stars as proof. And Ptolemy bought it. He must not have known about the tuft, at the end of Leo's tail. And they celebrated. Now, various astronomers through the centuries have kept that story alive in their charts, treating these stars as a separate constellation. And Coma Berenices was ultimately adopted by the IAU, making this the only constellation named after an actual person. The cascade of stars was actually an open cluster hiding in plain sight. It wasn't until 1938 that it was called an open cluster when Robert Trumpler identified 37 of the stars as related. It is now cataloged as Malot 111 and commonly called the Coma star cluster. It has 50 member stars spread over 6 degrees, including many in the 4th and 5th magnitude, like those labeled in this simulated binocular view, but not including Gamma. It's much, much closer to us than the rest of the cluster, which is 280 light years away. Only the Hyades is closer at 153 light years. And the stars in this cluster are 450 million years old, quite young. It's a great target for stabilized binoculars. Now let's turn around and take a look north. April and May are excellent months for observing two galaxies that lie on nearly the same line of sight. Messier's 81 and 82 reach an altitude of 64 degrees when they cross the meridian around the start of night in late April, making this the best time to observe, sketch, or photograph the pair. We're looking through only 1.1 air masses 26 degrees from the zenith. So that means the vision won't be degraded very much at all. To find the pair with 10 by 50 binoculars, you can scan diagonally across the bowl of the Big Dipper from Phecta to Dubhe, then continue for the same length in the same direction, and with any luck, both galaxies are in your binocular field of view. But scanning 20 degrees or so with a telescope, that's difficult. If you're using a telescope, start with Nu Ursae Majoris. That star and the galaxies lie on almost the same line of right ascension. They differ by only 5 minutes. So in other words, the galaxies are almost due north of that star. If you center Nu Ursae Majoris in a wide field of view, you can just scan in declination towards Polaris to find them. M81 on the left and M82 have interacted, resulting in starburst activity in M82. M81 is known as Bode's galaxy. Johann Elhert Bode found it on New Year's Eve, 1774. I guess he didn't have a date. It is a grand design spiral galaxy pegged at 11.7 million light years, using the period luminosity relationship in Cepheid variables that was identified by Henrietta Leavitt 111 years ago in 1912. The Hubble Space Telescope was used to identify and monitor those variables. The galaxy is bright at magnitude 7, easily seen in any instrument. The narrow appearance of M82 gives it the nickname the Cigar Galaxy. It was also discovered by Bode on the same night, and it's the second starburst galaxy we're taking a look at tonight. It is the closest starburst galaxy to Earth, so it is the prototype and is extensively studied. Like NGC 2903, within the central 2,000 or so diameter from its nucleus, again, 700 solar masses of stars are being born every year, similar to 2903. And the result of that starburst activity is the interaction it had with M81 earlier. Most sources refer to M82 as an irregular galaxy, but two spiral arms were discovered in near-infrared images in 2005, but those are hard to see in optical wavelengths. Imaging brings out enormous red-colored bipolar outflows of ionized hydrogen flying out into intergalactic space. The gas is being jettisoned by the energy of intense solar radiation, solar winds, I should say, from that starburst activity, as well as supernovae explosions. So M82 may not be in a regular galaxy, but it sure looks peculiar. Later into the night, you might like to see what's rising in the east. Here you will see the approach of the summertime constellations. Hercules and Ophiuchus are rising, and the Sagittarius arm of the Milky Way is coming up right behind them. Now, these targets for the summertime will be discussed by those presenting the sky this month at upcoming meetings, but you might like to check some of them out now because there are no mosquitoes, right? Yeah. Now, returning closer to home, let's take a look at our solar system this month, starting with the sun. Watch this circled area in this magnetogram video as it crosses the Earth-facing meridian when suddenly, right about here, wham, there it is. It suddenly, an active region surfaced so suddenly it caught solar watchers by surprise. As of this morning, the region, now numbered 3270, boasts 15 sunspots. It was graded as a Delta-class region yesterday because its positive and negative field lines have concentrated and separated from each other. In other words, you can draw a line between them. When this happens, strong arcs or loops emerge, rising up from the dark blue and plunging down into the red, and that can rip open and produce flares, which can produce auroras or disrupt radio propagation on the sunlit side of Earth. Definitely, this is a new region worth watching. Now, for some reason, the Delta classification was dropped this morning, even though you can still draw a line between the opposite sides of polarity, like I just showed. And the probability of X-class flares has jumped from 1 to 5% today. So I really don't know why they dropped the Delta designation from this. Was it a mistake? I don't know. But definitely this area with those predicted possibility of flares and so on, this is an area definitely worth watching for the next little while before it rotates out of view. Now you can check auroraforecast.com to see the next 3 nights of probability. This is a slide from last year, but you can always visit auroraforecast.com to see what's coming up. And that's just one of many websites out there that can give you forecasts of the possibility of auroras. The number of sunspots for solar cycle 25 has exceeded predictions since the cycle began in mid-2020. The peak is predicted for mid-2025 with monthly counts around 125, but we've already breached that predicted max count with nearly 150 at the start of this year. After a series of underwhelming cycles, number 25 has reversed the trend. The moon this month. The limbs tilted our way by libration are illuminated, so you can try catching the Petite and Glushko craters this week, and the Abel and Helmholtz craters on the opposite side at month's end. Perigee occurs on the 16th, and the moon appears 9% smaller at apogee 12 days later. This is how the moon will look to our guests at the public star party at Millennium Square on Friday, April the 28th. That's my third and final plug for the event. I'm running out of slides. The moon will be 1 day past first quarter, and that's the perfect time to view Rupus Recta, a 110-kilometer fault that stands out when the sun is at just the right angle. The fault looks steep when it casts a dark shadow. Its slope, however, rises 300 meters over 2 to 3 kilometers, a 10% incline. So with a bit of effort, you could walk up this so-called cliff. Rupus recta is Latin for straight cliff, though most call it the straight wall. Further south along the terminator, you can find the central peak in well-defined crater Tycho. That central peak is just reaching up and catching the first sunlight. Throughout the night, the shadow on the crater's floor slowly recedes to the moon's east, exposing more of the central mountains. Tycho is a relatively fresh crater, only 108 million years old, and that's based on samples of ejected material in the crater's rays that were returned to Earth by Apollo 17 astronauts. The crater measures 85 kilometers wide and is 4.8 kilometers deep. The crater's rim is sharp and intact, not broken or worn from subsequent impacts like its neighbors. The walls are slumped and terraced, and the crater's floor is flat and mostly unbroken. Now, Tycho's prominent rays of lighter material ejected by the impact, they stretch as long as 1,500 kilometers around the moon. Darker material was also kicked out and deposited immediately around the outside of the rim for about 100 or so kilometers, and that gives the crater a black eye appearance during and near full moon. The crater was named after 16th century Danish astronomer Tycho Brahe. There's a lovely pairing of the moon and Antares, one of the largest stars visible to the naked eye. As they rise together very late on Saturday night, April 9, they come closest at 2 o'clock in the morning on Monday. Antares has a radius larger than the orbit of Mars. That is big. When Venus is an evening star like it is now, we can anticipate attractive pairings with the crescent moon passing by each month. Did some of you see the beautiful pairing of the moon and Venus back on March 23? That was gorgeous. There's a repeat coming up on April 22 when a 2-day-old thin crescent moon slides midway between Venus and the Pleiades star cluster. On that same Saturday night, April 22, the Lyrids, the meteor shower, it peaks. Now, because the shower radiant is close to Vega, Alpha Lyrae, it's called the Lyrids, although its radiant is actually in Hercules. The thin crescent moon will set soon after sunset, so it won't interfere. The peak is around 9 p.m., just as the radiant is rising, but 17 minutes before the observing window opens. In other words, you can expect to see Lyrid meteors as soon as the sky darkens on that Saturday evening. You can expect to see 10 or more per hour, and I have found some predictions on some websites that were a bit more optimistic, supposing 20 or so. Now, after midnight, the eastern horizon faces the direction of our orbit, adding our orbital speed of 30 kilometers a second to the meteor's incoming speed of 18 kilometers a second, giving us the 5th fastest of the meteor showers. The Lyrids have the potential of producing long trails. According to Don Mackholtz, who writes for Earth Sky website, he said around 1 out of 4 Lyrids leave a glowing trail of ionized gas that can last a few seconds after the meteor has passed. 1 out of 4, I hope he's right. That would be amazing. The meteors come from debris shed by a long period comet discovered in 1861 by Alfred Thatcher. Comet Thatcher has a 415-year orbital period, so its next perihelion won't come until 2276. Now, this shower has the oldest recorded observations dating back to Chinese accounts from 2,700 years ago. Now, let's check out the planets, starting with the inner solar system. Each dot represents a day. Mercury reaches greatest eastern elongation from the Sun on April 11 on its way to inferior conjunction on May 1. Throughout the month, Earth is orbiting away from Mars while Venus draws ever closer on its way to its own inferior conjunction in a few months. You have a great chance to spot elusive Mercury on the evening of Tuesday, April 11, just 6 days from today, when the little world will be 20 degrees east of the sun. You should have no difficulty spotting it in binoculars after you wait for the sun to set. Once you know its location, you can find it naked eye. And you don't really have to wait until next week. You can try any clear evening. In fact, I heard on the way here that we're going to have clear weekend. This coming weekend should not be like today. It should dry out, and with any luck, we'll have clear skies, and you can start searching and finding Mercury as early as this weekend. You might detect its phase under very high magnification if the air is steady. At least Stellarium can do it. Venus is already high in the west after sunset, right? And it will continue to climb all month. Here we see it at 10:40 p.m. each night, climbing higher as the background stars sink. In the west, Venus will reach its furthest point east of the sun on June the 4th. Now, as Venus approaches us, its apparent size and brightness will increase, while its phase decreases from 3/4 illuminated tonight down to 2/3 by month's end. And when this clip finishes, when it reaches May 2, there we see 2/3 illuminated. On April 11, that's the evening you're out spotting Mercury at its highest. Take a moment also to look up here and notice how beautiful Venus is right next to the glittering Pleiades. They make a great grouping, and together they make a great photo opportunity. Here we see them framed in a typical DSLR with a 300mm lens, suitable for your living room. Well, maybe not that big, but you know. It's springtime here, but fall for the Curiosity rover on Mars. In January and February, the rover took these stunning pictures of crepuscular rays shining through clouds at sunset. To get a good look at Mars from your backyard, or at least a look at it, look for a red dot about halfway up the western sky after dark. Here we see Mars's position at 10 p.m. throughout the month. Mars will travel east, up through the Gemini twins, while the background of stars sinks lower to the west. While sliding to the east, Mars comes particularly close to Epsilon Geminorum on Friday, April 14. At the start of astronomical twilight, the two are 13 arc minutes apart. Mars is only 6 arc seconds wide on the 14th. About the only thing April 2023 isn't good for is the outer solar system. Jupiter and Uranus are hiding from us behind the sun all month. And even Neptune, when it rises in the east, is so close to the sun's rising that dawn's twilight will wash it out. That leaves us with just a couple of pre-dawn hours with Saturn and a shot at Pluto for those with really big telescopes. If you get up before 5 in the morning in the last week of April, you can catch Saturn rising during astronomical twilight. The planet is located in Aquarius, and you will need strong magnification to examine the planet and its rings this early in its 2023 apparition, when its apparent size, including rings, is around 38 arc seconds. And if you do get a good look at the planet in your telescope, you'll notice that we are close to crossing the plane of its rings, which occurs every 15 years. We'll see the rings edge on in March 2025 as we pass south of the Saturn's equator and ring plane. And that's all I got for tonight. Are there any questions?
We have several questions online. First, I'd like to say that Kyle Gant and Jack Mayer say hello, and we're watching online. We also have a question from Zap Fan, who has a point. If you visit Sweden, you can visit Tycho Brahe's island haven. Some of his instruments have been redesigned, but his castle is gone. Tariq Al-Hamrani has two questions. So his first is, so this is for the Northern Hemisphere. What about the Southern Hemisphere? And his second question is, also, me being in Northern Hemisphere, will the sky be different from my latitude, 25 degrees north, than others who are much farther, much further in north?
Yeah, so I can definitely work on the second question. I did not study the sky for the month of April in the Southern Hemisphere, but I can tell you that you can see the same planets. You'll see the moon slide between Venus and the Pleiades. I think you should be able to see that. The Pleiades can be seen all over the world. Being close to the equator, it's visible in all continents. So I think some of these highlights I may have mentioned, the ones involving planets, yes. Of course, the sun, if we do get auroras in the Northern Hemisphere, you get the exact same thing in the Southern Hemisphere, I believe. I believe that they're mirrors of each other. But I'm not 100% clear on that. I say that with a little bit of uncertainty. But I would imagine most of the other highlights that I talked about, seeing Saturn crossing the ring plane in a couple of years, yes, that's visible from the south as well. Now, the second question, remind me again? Further south, yes, of course. The further south you are, the higher the planets will appear. So I would imagine Mercury will be even higher up the further south you go. I'm pretty sure about that. But not 100%. A lot of the stars that you can see at 25 degrees, looking at the southern horizon, looking at the lowest stars you can see, are a lot more than what we can see up here at 40 degrees. So you have a much richer field of stars. You'll see more constellations. You can see further south than we can up here. So if we can see it, you can, and chances are you can see a bit more. I hope that answers your question.
Thanks, and that's all the questions we have online at this moment.
Very good.